So hello friends, welcome again, and today we are going to solve a new question, and this question belongs to our tree series, and the question is populating next right pointers in each node 2. In this question you can see that we have been given the structure of the binary tree, and it is different from your normal binary tree where you have value left, right, but here is an additional pointer which is next pointer, and the question revolved around this pointer only. Here, what we have to do is that we have to populate each next pointer to the point to its next right node. If there is no next right node, the next pointer should set to null. Initially, all next pointers are set to null. So we have been given this structure, and here you can example you can see that all the left and right pointer are positions and pointing to its correct position, but the next pointer are initially pointing to null value. And what we have to do is that we have to point it to the node which is just next right to the current node. So if there a node exists in the right side of a current node, then we have to point the next pointer to it. And if there is no node which exists to its right part, then it is pointing to null. Here you can see that the root node doesn't have any node on its right side, so it is pointing to null. But in second layer, you can see that the value root node 3 is on the right side of the 2. So 2 next is pointing to 3, and there is no node in right side of the 3, so it is pointing to its next pointer is pointing to null. Similar condition in the next or the last or the leaf node. So this is the question, and let's understand how we can approach this question and try to solve it. So here you can see that I've taken the example one from the question, and you can simply see that we already been given a binary tree. But only thing we have to do is that we have to try to point the given extra pointer, which is next pointer. Now the point to notice is that the every activity for the pointing of the next pointer is happening at a level. That means at each level you have to check that if there is a node on the right side or not. If it exists, the next is pointing to the node, and if there is no right node, that means you have to point it to null. So this is the question. So simply you can see and simply you can analyze that this question asks you to perform level order traversal, because all the functionality or all the approach which you have to do in order to satisfy the condition is being going to be satisfied by level order traversal, in which you go through the tree in level order. So it is a BFS. So we have to perform BFS. Now let's understand how you can use BFS in order to solve this question. Now here you can see that I have taken a Q data structure, and in the Q data structure what we have done is that we have placed the first root node inside it, and the one important thing is that we have also placed an integer value which is the level. That means if we are placing the node from the first level, we are putting 1. If we place the node from the second level, we are going to place 2. So let's start our traversal. So first we have done is that we have placed our root node. So after this, what we're going to do is that we are going to search for the left and right. So what we simply do in such steps, that we first take out our root node. So we first take out the current node, and what we do, we search for the left and right. So before that, what you can do, you can check that if we take out this node, we check that if the queue is empty, or it consists of any nodes or not. So if there is no node, what it simply means that it is the first level or it is the last level. That means there is no nodes on the right part, it is clear. So if there is no node in the queue, that means we do not have to do anything, its next should always going to point to null. So now it is clear. Now let's move on to its left and right part. So after this, what we do is that we put its left and right part, which is 2 and 3. So let's do that. So here we have placed the left part, and here we have placed the right part. Now let's see what happened next. So in the next traversal, what you do, you take the top front value, which is your 2 comma 2. So we take this, and after taking this, what we see that if there is node present in our queue or not. So you can see that there is a node exist in your queue data structure. And one another thing is important to consider is that if it is on the same level or not. It is important because we have to point your next pointer in the same level. So we check that yes, our the both are on the same level, which is 2. So what we can do, we can simply point this 2 to its next value, which is 3. Now this is complete. Now after this, what we do, we simply do what we simply do. That means we simply call for left and right for 2, and we place 4 and 5. So let's place 4 and 5 in our queue. So here we have placed 4 and here we have placed 5. Now let's move to the next node, and the next time what will happen, it will take out 3 comma 2. So when we take 3 comma 2, the first condition which we are checking, that if there is node in the queue data structure or not. So yes, there is queue data structure and there is our nodes. And the second condition which we are checking is that if their levels are same or not. So here you can see that their level are different. The current one is 2 and the present node in the front is at level 3. That means the node which we have in our hand is the node in the right part of that level, current level. That means it is the last node in that level. So we do not have to do anything because its next is already pointing to null. Here you can see. So next what we have to do, we again take this 4 comma 3 and we again check the conditions. First, yes, it one thing we forgot, that we also have to put the values. So what we can do, we can move to left and right. So there is no value in the left, the 7 is on the right, so we place the 7 in the queue data structure. Now next what we have done is that we have taken our 4 comma 3, and when we take the 4 comma 3, we again check the same conditions. Yes, there is a node and it is in the same level. That means the 4 next is going to point to 5. Okay, now after this we call for left and right, so there is no node, so there is no addition. Now next we take 5 comma 3 and again we check the same condition. Yes, they are on the same level and there is a node, so this 5 next is going to point to 7. Similarly, there is no left and right. Now we move to the next node, which is 7 comma 3. We again check that if there is node present in the queue or not. So here you can see that this is the last node in the queue. So there is no node. That means it is the last node. That means it is the last node in that row. So what we need to simply do, we can simply escape. So this is the complete process. You have clearly understood what we are doing. We are taking consideration of the each level, that on which level we are currently present at, and we are pointing the next pointer if there is a node right to it. And if it is a rightmost node, then we do not need to do anything because it is already pointed to null. So this is the complete illustration how we can solve this. Now you should try on it your own. Now after this we are going to code it. So now let's start, and the first what we need to do is that we are going to check that if our node or root is a null, that means if it is null, so what we can do, we can simply return null. Simply return root or null. It is simple. Now next what we can do is that we are going to take a queue data structure because we need to perform BFS. So we are going to take queue, and it is going to take a type pair, and this pair is going to consist of the two values, which is first is node star, and the second is its level, on which level it is present. Now next what we can do, we can first insert the root node. So we can do q dot push make pair. And what is the pair we have to make? We have to take root comma its level, which is going to be 1. Now next move to our while loop. So we are going to run a while loop while our queue is not empty. While our queue is not empty. So when it is not empty, what we have to do? So first thing, we are going to take the front value, which is going to be our first node. So we are going to take node the star temp is going to be our q dot front dot first. So this is the first part we have got. We got the one, which is our this root node. Next we need to get its level. So we are going to take int level is equals to q dot front dot second. Okay, dot second. Now after this we are going to check the condition which we have discussed, that if our root is not if our queue is not empty, that means if our q dot ty, that means if there is nodes, then only we have to check. And what we need to check is that if the levels are same or not. So first level is our L. So if it is equals to your next node, so before that what we can do, we need to pop it. So what we can do, we can write q dot pop. So what it will do, it will automatically pop the front element. Now, if we have already popped it, that means the next is going to be checked. So what it's going to do is that we are going to check if our q dot front dot second. So if we are able to get that if the value is present at the front of the queue data structure level is equals to your current level, then what we have to do, we have to point its next pointer. That means your temp next is going to point to your q dot front dot first. Okay, after this we have to simply do the BFS. That means if our temp left, we can simply write q dot push make pair, q dot push make pair. And what is the pair we have to make? So the first pair is going to be our q left. So temp left comma your l plus 1. Okay, similarly we have to do for the right, so we can simply copy this and paste it here. So if our temp right exists, then we have to push q dot push make pair temp right, and simply we have to increase the level because we are moving downward. Now after this we simply need to return our root. Now let's test this. Okay, so we have forgot here one arrow. Now let's run again. Okay, so this is accepted. Now let's submit this. So the submission is successful. So this is the question for today, and this is a simple question because we have utilized the concept of BFS. So it is in important of term to understand the use of BFS in order to solve this type of questions. Now you will see the solution for both Java and Python. So stay tuned and let's meet in the next video and solve more interesting questions on tree. So thank you and have a good day.